Hello everyone, welcome back to my YouTube channel. Basically, today I'll be taking you through our AI stock prediction model. Basically, I told you initially we were making a linear regression model. Basically, what we shall look at in this chapter, we shall look at the heat map, correlation matrix, box plot, and other features to follow as seen in the contents. Then talking about the heat map is basically a graphical representation which uses color frames, basically in terms of intensity and density to show patterns and showcase relationships between variables in our data set. It's essential for establishing that relationship as to as it helps visualize the results of machine learning the machine learning model. Basically, this is our heat map. As you can see, the heat map we generated it from our correlation matrix. Basically, this is how it looks like, and it shows us that the percentage of it is, the majority of it is less than 0 point. I mean, it's greater than 0.8, close to 0.9 around there. So that means our relationship is high because we used our correlation matrix, except for the part where we have the volume and the other features of the data set. We can see that the correlation is very low. Then coming to our correlation matrix, we know that the correlation matrix helps us basically also establish a relationship between two variables. Um, the features of correlation matrix, if it ranges from -1, it ranges from -1 to 1. But where it's -1, it shows a strong negative correlation. Where it's 0, there's no correlation. Where it's 1, it's a strong positive. So for our data set, we're able to obtain the following correlation matrix, whereby open and open correlation is very high, high and open correlation is also high. It's a high positive because we can see it's 0.9, open is 1. So basically, the correlation between the features was very high, except when it came to bandwidth volume. Then we look at box plots. Box plots help you get a better understanding of the whole model to analyze data before you process it, and you're able to identify outliers through a box plot. So we're able to do this box plot for our data set, and we found out that we had many outliers actually, because from the year of 2010 to the year of 2019, the values were kind of small for the stock prices, but after 2019, the prices shot very high and rose to figures in hundreds. That's why you have the box plot in such a case. Then we look at the future independence plots. These help us visualize and show relationship between different features in a data set. They help us assess the independence of features, which is important during making the assumption, during many processes like learning algorithms, also including linear regression. To illustrate this, we used a scatter plot as it can be used to analyze a future independence plot. And we found out that from the year 2010 to the year around 2019, 2020, the price values were very low. And from 2010 onwards to 2022, the prices shot at a very high speed and continued to rise drastically. Then outlier plots, as I told you before, we're able to determine outliers from a box plot. For this case, our outliers, we're able to determine them using a box plot, which I earlier showed you on. And the outliers usually lie above the whiskers of a box plot, whereby the whiskers, if we look at, let me give an example of the next slide, the illustrations of patterns of interest. This first one here is a box plot. Now the whiskers are that line before you, before the outliers start appearing. Those little circles are our outliers. So the reasons why we chose this as as the patterns of our interest, we tend to see there are many outliers, and for accuracy and for for your model to work efficiently and do the right thing, you shouldn't have as many outliers as we have seen. So that's why we took it as the pattern of interest to us, and also the scatter plot. It helps us know the pattern of the prices, and we know the right and appropriate actions to take. For the illustration of trends in time and space, as we have seen before, from 2010 to 2019, around 2020, price rises drastically but doesn't overshoot up. Then from 2020 to the current year, which is up to now, the price ranges shot up at a high speed, and it gives us quite difficulty. So that is how the general trend was, but we're yet to see how we overcame these challenges. Then for our exploration and data cleaning, basically we're able to analyze our data, look at its features, and we checked our data to see whether it had null values, missing values, and it didn't have any of that, and we're able to clarify that our data was clean and usable, and we proceeded to the next steps and built our model. The next procedure was splitting our data, but due to the outliers, we found out that we couldn't split that data immediately. What we did first was to split the very low values and split the very high values into two categories, ones which kept on rising and ones which were slightly very low, such that we eliminate the problem of the outliers. Then we went ahead and split our data into three categories for both of them, for both the high and low data that we obtain. We're able to get the training data set evaluation and the test data set. Using the code as seen below, we're able to do that, and we're able to eliminate a lot of outliers which shall be seen in the future. Then for our model, uh, we we used two models. Basically, the first one was using the very low values, which is illustrated here. We plotted the very low values, and we're able to generate a line of regression using the linear regression model. And we can see the red line is the predicted, then the blue line is the actual line. So this was the model we used. Then for the ones of the high values, we're also able to plot a graph, and then we joined both our findings for both models to avoid a lot of biasness and to be able to get accurate results. Then tuning the hyperparameter as I told you, we divided the data sets into two. The ones is very high and very low prices. For the ones with very high, we're able uh, to plot, make a box plot, and we didn't have any outliers. So that data set was very usable. Then as for the ones with very low prices, we found a few outliers like two, three, which we actually which can be eliminated by making those outliers have values at the extreme end, at the whiskers end. So basically, we can see that now our data is usable in this format. For evaluation and validation of asset, we took upon the metrics for linear regression, whereby we used the mean absolute error, and also we used the error squared error, which which helped us know the evaluation and validation of asset, how accurate it is, how efficient it is, and basically that is how our model looks like, and that is how we shall be able to predict. And for prediction, we shall be using the close the close variable or feature to be able to predict the stock prices at a later stage. Now that's the end of the presentation. Thank you.